Good morning, everybody. Good morning, everybody, or whatever you are. Good, like, hopefully you are having a good time. We are back with another video, and this time it's turn for 3.26. Write a function def that returns the maximum path length from the root of a tree to any leaf, and that's all. That's all she wrote. Okay, okay. This is like the problem, and we have to provide the solution. And you might be tempted, and again, we will be taking a lot of the time in here because I don't want to be, speaking and this time interrupted or stopped. And I my own being just talking to no one. I actually talking to no one, like there is no any concurrent viewers. So, but uh, for the streaming, like okay, talking without streaming. All right, so okay, 2 minutes. Time flies for sure. Write a function depth that returns the maximum path length from the root of any of the of a tree to any leaf. Let's get over here. And we have this URL in the description if you want like starting code, because there are no any more property-based testing like at the beginning. You can have a battery of tests in the official GitHub repository for this book. Well, I'm going to get rid of this dummy. No more dummies. I'm tempted to get rid of these two, but maybe in the next session, one step at a time. Okay. Let's get started. First, with the type, it will operate any tree. It is not constrained of trees of type int, so it will be an extension of this tree of int. So it will be over here. You can place it down below, but to keep things organized, with the proper indentation, to keep things a little bit of organized, let's be over here with depth, 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 tree of types A. Sorry, that's the type variable T, which is a tree of type A. And taking a look at the size, which is just above, we are returning an int, because it is the path, T match. Okay, here I don't want the cases automatically added because what do we put in here? I brought once again my chalkboard and if we receive this tree, we are lucky. Hopefully the function is just for leaf. we got this number is the depth of the tree, which is great if you ask me. So let's encode that beautiful diagram over here. Case leaf of I don't care is just one, which is amazing. The next case, let's go back to the first to see if we are alive, still alive. Yes, we are still alive and kicking. And okay, now if someone, I'm using the depiction of the books, he has, the author has this, the author person that wrote the book is like having these diagrams. This, maybe I went too complex, let's do it with leaf. Mm-hmm. 3 and 5. I don't know why 5 comes a lot to my mind. 7. So 3, 5. What's the depth of this tree? Well, it's 2. Why? Because there is this branch exists, and this is a path 3, and this is another path 5. If you're tempted to use size to reuse it as if, you will be returning 3, because you will have 1, 2, 3. That's not the depth of the tree. And maybe you can say, okay, is the depth of the tree -1? But then the tree can grow even further, I really like these diagrams. Okay, here's enough, because you get the idea. And 7, you say 1, 2, 3, 4, 5 -1, you get 4. 1, 2, 3. And you can say, oh, it is. You maybe will come with some mathematical formula. And like the ones that include n factorial divided by n -1, things like that, And that will be great because you will have a constant time algorithm. But at this point, let's go with another approach. And we will have 1, 2, okay, 2. In the right side, look at this. Right side, the right side. 2, 1, 2, 1, 2. Maybe I'm not sure if I got the right definition for that. I suppose this is 2. Now we're here. 1, 2, 3. For here and for here, we have 3 steps, 3 def, and this is what we are going to use. We want to focus on here and return 3, and we want to focus on this and return 2. Then we want to take those two values and return 3. That's great, but how do we write the code? But that's it, that's the solution. That's what we have to do, and hopefully there will be a time in the future in which you can say to the computer, here's some diagram, here's why I'm thinking. The machine probably will know what you are thinking. I don't know. I'm talking far, far away in the future. And okay, here's what you want, the computer will say. And we don't know what form the computers will have. This is like still the science fiction. Still the science fiction. Okay, at this point, you can ask for an assistant, write the solution, and save a lot of time, and go play basketball and some video games. I don't know. But if you want to grow as a problem solver or as a functional programmer, computer programmer, you will have to at least try hard, very hard. And if we don't get the solution with this approach, I will end the stream because I'm not spending the entire day like many years ago in one single problem. I'm not sure if that's healthy. Unless you are getting paid, or unless you have one unique hobby, like mathematicians in the past. Okay, let's encode this. 12 minutes in just talking. Sorry, some people will say just keep the thing back to where is it? All right, let's case branch with the left side and the right 3. The mind always wants to escape the avoid thinking unless you are like very disciplined. So my mind wanted to come here and look at these 3, and in here we expect 2, I suppose. 1, 2, 3. Branch, yeah, 3. Let's well, at the end, let's one thing at a time. Be organized. Back to thinking. Oh my. Again, if you are tempted to use size, you will get a lot of multiplication with these numbers. So it will be something like this, I suppose. And remember, we have the max function from yesterday that we were interrupted. No, on Saturday. Yeah, we have this. So we want 3 over here and 2 over here. 3, 2. Maybe I should put another camera so you have 2 angles, and you see when I look down below, there is nothing here, just my keyboard, but I cannot see because it's like this. Maybe in the future, if you kind of support this endeavor, you'll have no, more things to show. 3 point max. How can we come up with this expression? My God. I will use some form of this. I don't know what to even write. Well, let's just start with some parentheses plus def. Just finish the thing and go to do another thing. Uh, now we want this to return 3, hopefully, and uh, this is our 3. Now we want 2. It will be another parenthesis. Please tell me that this will work. Right. Okay, look at this. 3 parentheses. Now what? Uh, yes. Remember, we want, what do we want in here? Okay, it's a branch, please man. Let's put this thing over here. Branch -5, 9. Are we still online? Oh my God, 17 minutes. Too much talking, maybe that's refraining us to solve the thing, but that's the intention of this show, because this entertainment, just the case in the future, you know prefer to see this instead of any other thing. I don't know. 2099, we will have one, one, two, three, -3. In the morning, I did have this algebra refreshing in YouTube. I just look back because I have some books, but I didn't read the algebra books. Algebra. I decided to see some videos instead because they were more easy. They were more easy. 3, 1. Okay, and we want this 3. Well, I did it with the mouse. So let us, let us hope for the best. And if the thing doesn't work, oh my God. 3. Wow. Maybe that is a coincidence. Let us encode some other, another. Let's comment this. 3, 1, and now let's just have this leaf. which is silly. This test is silly, but such is life. One. Okay. Last one. What kind of treat do we have? Do we want to go 20 minutes? Hopefully you are enjoying me talking this nonsense. And if you prefer just for me to shut up and write the solution, that's okay. Just make sure to impact the priority and the form of this stuff via my website. There is a way in which you can impact all these things. You know, you are in control. Take a look and discover by yourself how you can, you know, change these things. Okay, now another. I think we are going with some silly. Last one, something like this. We will have to love over here. Maybe here, 9 only. You have uh, two. This will be, I don't know, like tedious doing code, right? Here's, that's a 5. 1 circle. Uh, Again, your number of marble. 399. How? What's the answer over here? Let's see. So we will have 1, 2, 3, 4. 1, 2, 3. And we want this to appear. But again, this is like we will see if we can encode this because it's kind of cumbersome. Let's start with the branch. I'm going to put some spaces at the beginning just to be, you know, and then we delete the spaces. Branch, 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 branch. Okay, branch, branch, and here we are done. 2, 5. And here we have another thing. Branch and leaf. Branch, leaf 9, and 1 to 39. You know, if you are into this stuff, you can write a parser for these expressions and come up with some diagrams. I'm not sure if this is the right encoding. Should be falling here. We have more confidence. And someone will say, what if your I have a tendency to write the stuff over the left and not the right. What if you have these three? Someone will say, which is a variation of the first one. So maybe this is just waste of time for you. Sorry. What's this? It's like 11. This is okay. For this, it's just we are done. And in here, 1, 2, 1, 2, 3, 1, 2, 3, 4. We ended into the same number when another number. Let's go with this. Just 1, 2, 3. We have 2. 3 and 4 already appeared. Maybe 2. So the maximum is 2. And this is another form of the 3. But still, if you need even more confidence, you should come up with some test strategy. This is just like for fun. And yeah. Okay, I don't want to erase this because maybe we will, the next functions, maybe we will need some trees, and it is better for us to have this at hand. So we need only a tree with 2 if this parent 3 leaf. Okay, we are done. This is like the solution. It is a variation of this. If you at the beginning were tempted to say, I will reuse the size, and you will end up with the double, and maybe you can double the number of nodes. Well, no, maybe you can. I'm not sure right now. I'm not thinking in that strategy. And maybe you can say that I will divide by 2, but I'm not sure if that will work. So we will save this for next session. We are done. Thank God. Let's wait for the 30 minutes and then the thing. We have 1 minute to do the ceremony. Last famous words. Okay, what can we say in 1 minute about trees? Well, it's a recursive definition, a structural over the tree structural recursion, using Max from Saturday, yeah. And it is not an extension method to int trees of type int because we want the depth of any type of tree. Left, right completely, because if you write L R R, this will be confusing there. But that's okay. Maybe you will find that in code bases. I'm not sure. This is enumeration, beautiful. And let's count 10, 9, 8. Thank you very much for being here. Bye for now. See you later.